Hello, everyone. Welcome to our final project presentation. Our group is Machine Learning and Commercial Real Estate. I am Koa, and my other teammates are Yantong, Brian, and Amanda. For this project, our client is BuildUp. BuildUp is a startup SaaS platform that provides valuable data for real estate investment and development. BuildUp tracks construction through its entire life cycle by programmatically collecting data from many sources to track construction projects throughout their life cycle. BuildUp clients can use this data to learn about construction, what's going on in their area of interest, and maybe identify leads for their business. Our project mentor is Andre. He is the CTO at BuildUp. So some background on our semester-long project. The BuildUp platform currently collects many permit data from sources around the nation, and some of those sources don't have permit classifications. And BuildUp really depends on the permit types to be able to automate the status updates of each construction project. So our goal for this project is to architect, train, and deploy a machine learning model as a microservice integrated into the BuildUp platform that enables permit classification prediction to allow BuildUp to achieve a greater level of automation. So the purpose of this project is to enhance real estate data for BuildUp clients. As an example, on this page right here, at 33 Braddock Park, currently this project is being labeled as status unknown, and that is because BuildUp is unable to receive the permit classification for this project. If you're a BuildUp client and you potentially want to partner or make an investment in this project, the lack of data on this project will hinder you from making a correct decision. So that is the valuable data that the client must have regarding project descriptions and project data. Another motivation for this project is to reduce BuildUp costs by automating data labeling. Currently, BuildUp has a small team that manually labels some of the data, including permit types as well as news data regarding projects. If we can make a generalized machine learning model to predict permit types or permit categories that can be inferred from just a plain text of some sort of permit description, then it will greatly reduce BuildUp costs.
Our MVP for our project is a trained model that can accurately predict the classification of a permit based on its text description and is deployed as an endpoint of an API that can be called repeatedly within the BuildUp infrastructure. So we have a machine learning model that is used by a web API that runs inside a Docker container as a machine learning microservice. So now we'll go over our whole semester sprint plan. So for sprint 1, we met with our mentor, Andrew, and he walked us through the website and talked about some of the shortcomings that he was aware of that were currently on the website, such as missing data, missing permit classification, missing project descriptions, and missing images. And so we spent a lot of sprint 1 exploring the BuildUp website to familiarize ourselves with the scope and implications of the project. But at first we weren't exactly too sure how to address these problems or if we wanted to work on multiple machine learning models simultaneously. But after talking with the professor and the mentor a few more times, we had a better sense of what direction we wanted to head in. So we planned to work on one machine learning model that addressed the permit classification shortcoming of the website. And for sprint 2, we found an academic research paper that tackled a similar problem that we were trying to solve. So the paper provided us with excellent methods to devise a solution for our project. And we also learned a lot about what machine learning models we could use. And the results of this paper served as a baseline for our work. And also for the sprint, we cleaned the Boston Public permit database for training. And so for our first model, we use the permit number, work type, description, and comments for training. And we ended up getting 100% accuracy. But we realized that there was a letter in the permit number that corresponded to the permit type. And so our model was probably using this letter to classify the permit. And this was not ideal because we wanted to use the description to classify the permit so that we can use our model on data from other cities as well. And lastly, for this sprint, we set up a simple hello world Python server.
For sprint 3, we trained a model on Boston data without the permit IDs. In our previous iteration of the model, we trained the model with permit IDs, and we were able to achieve 100% accuracy. But that's not the purpose of machine learning. And we can probably write a script and be able to obtain the same accuracy. So for this model iteration, we completely remove all the permit IDs as well as the work type and the permit number and description, and we just trained it on the comments of the permit, which was a general description of the permit. And for the Boston data only, we achieved 90% accuracy. Our model architecture is to the right here. First, we have the input layer. Second, we have the pre-processing layer, which uses the BERT preprocessor. Then we have the BERT model itself. And finally, we have a dropped-out layer and a classify layer, which in our case contains 14 neurons for the 14 classes. In Sprint 3, we also deploy the model on a REST API endpoint within the build-up infrastructure. So in this demo here, you can see that the model is currently hosted on a public IP address under the port 5000, and we're able to pass in a JSON input of strings, which are the description of the permits, and we're able to receive the classifications of those inputs that have the highest confidence. In Sprint 4, we work toward a more generalized model that can infer permit types from inputs that are not just from Boston. So the first step is to create a new mapping of permit types. And we wanted to create 4 generalized mappings that we can categorize more specific permit types into. And we chose electrical, building, mechanical, and plumbing. These are generalized categories, and they are also the same categories that was used in the paper that we consulted. After that, we decided to collect data from 2 more cities, including Austin and San Francisco. These are big cities that Buildup is currently trying to expand to, and they also provide a large set of data. We ended up collecting in total 4.3 million data points that we could use to train our model. In Sprint 4, we also explore how we should deploy a model. On one hand, we can deploy it serverless, which means we would have less resource consumption since it doesn't always run in the background. However, we would have high latency because our model, which is huge, 300 megabytes big, it would have to be loaded with every single inference. On the other hand, we have server deployment, which means we have low latency since our model is only loaded once. However, our server is continuously running in the background. That means it will consume a lot more resources. So after a consultation with our mentor, we decided to go with server deployment. Our mentor suggests that serverless deployment offers no real cost reduction in our case, and that the latency is a huge detriment to the functionality of the model. We also made our model deployment mechanism more robust. In particular, we added error checking on our endpoints for checking invalid inputs, and we also containerize the endpoint and resources within a Docker container. For Sprint 5, we trained a model using permit data from Austin and San Francisco in addition to Boston. Our model had 4 categories: electrical, plumbing, mechanical, and building, and our accuracy turned out to be 74.84%. The paper that we consulted had an average accuracy across 4 categories of 77.20%. So our model is definitely on par with the results of the paper, although it's slightly less accurate. We think the problems the differences could be because they trained the model using the real BERT, like the full BERT model, whereas we train ours using small BERT. We didn't have enough resources to train the full model. It's much bigger and it would take a much longer time to train. Additionally, they had input data from more cities than us. We have a total of 3 cities. They have 5 cities. In Sprint 5, we also automated the model deployment process inside buildup. We showed our mentor a demo of how we served the model on one of the REST API endpoints within a buildup server, and he wanted us to write a script to automate the process of fetching the model as well as setting up the environment and download all the dependencies without any work, any manual work. So we created a shell script that ditches that. The script fetches a large model from the drive where we host our models. It will then fetch the latest API code from our GitHub repo, and then it will set up the environment inside inside a Docker container, including downloading all the dependencies. And finally, it will serve the model on a REST API endpoint. After our Sprint 5, we met up with our mentor, and he appreciated our model of using the 4 categories, but he wanted a high accuracy binary model that's able to classify permits into a during construction permit and a post-construction permit. And this is more useful to build up because he says they really want to know the status of the construction project rather than the classification of each permit type. And so we split the 4 categories into 2 overarching categories. Electrical, plumbing, and mechanical belong to post-construction work, and building permits belong to during construction work. And we retrained the model on the same data from Boston, Austin, and San Francisco, and we achieved an accuracy of 88.45%. The accuracy is not as high as what our mentor expects. He wanted us to have a model that is greater than 95% accuracy. So our model results is less than the goal, but it provides a good baseline for us to improve in future work.
Now to our final product overview. For the project, we ended up working on roughly 140 points and tackling on average 23 points per sprint for a duration of 5 sprints. And here's our burn-down chart for the duration of the project from September to December. The main outcome of our project were the 2 working permit classification models, 1 model that predicts input data into 1 of 4 general permit types, a second binary model that can predict input data into 2 types of construction phases, during and post-construction. Additionally, we have developed an API hosted on the buildup server in order to call and retrieve information from the machine learning models. And finally, we developed an automated setup script that both sets up and deploys the models and the API onto the buildup platform without much effort. Now, we have accomplished a lot for this project, but it is not without its limitations. First, we did not get to use the data collected by buildup to train our model. Buildup has their own data cleaning pipeline, and making use of their data could have given our model better performance. On that same line of thought, we also didn't test our trained models with the data that buildup collects and cleans. Since they have data from many more cities than we tested on, doing this could have given us more insight on what more to improve for our model. Another limitation is that we only trained the model with the data from 3 cities. These cities were located in different regions of the US geographically, which gave us a good general model, but training with more cities would potentially increase the accuracy of the model even more. Regarding our model more specifically, it has some inefficiencies that we believe could be addressed with more fine-tuning of the model parameters. And finally, our API does not allow for much flexibility in the type of data input and output. Currently, it works with a list of strings and just returns a JSON object with percentage indicating the confidence of the prediction.
Future work. Our work is not perfect, and there are still a few things we can be improved. The first thing is that the image generation model. The image generation based on the text description is also one of the models our mentors wants at the beginning. However, due to time limit, we can't manage to do it in this semester. Second, we can have more city data like New York, Philadelphia to improve the accuracy of our model. The build-up team also need to use their own data to test and run this model. Third, the model can be improved by retraining with different parameters. In order to improve the accuracy, we also need to test and validate with different data set. At the end, the API should have new route to expand the type of the data return. You also need to support filters, support a build-up team to filter specific data using the API. Basically, just make the API more flexible and more functional, add more functionality. In this project, we have learned a lot from it. At the beginning, we struggled on the project description and have totally the wrong path. We fixed that and get into the right path in the second sprint. It's a very valuable experience for our future project and work. Also, during the development, we learn how to look out for suspicious results and make assumptions about the problem, and then fix them. We also take feedback from everyone and use them as the guideline to improve our solution approach. For this project, we use Scrum as our project management method, and we gain some practical experience about it. It is a very useful and helpful project management method for our future work. After that, we have some hands-on experience on the large data processing and machine learning development. At the end, we want to thank our mentor Andrew and the build-up team to support us to do this project. We also really appreciate our instructor to give us a lot of valuable feedback to help us to improve our project.